This lecture talks about the skeletal system. To start with, let's label all the bones in the human body. Number 1 up here around the head is the skull, but the name that you should be using is the cranium. Then we have the collarbone, that's the clavicle. The long bone in the upper part of the arm is the humerus. The individual bones that make up this column here are the vertebrae, or vertebra for singular. Now the 2 bones in the lower arm are the radius, which is in line with the thumb, and the ulna, which is a smaller bone in line more with the pinky. And then if we, even though they're not labeled, if we were to look at the bones in the wrist and the hand, the bones in the wrist are called the carpals, and then the bones in the hand are the metacarpals, and the fingers are called the phalanges. Number 7 is the longest bone in the body. It's the femur. The kneecap is a patella. Then we have the shin bone, which is the tibia, and the bone behind that is the fibula. Then we get down to the feet, the ankles. The bones in the ankle are the tarsals, and then the bones in the feet are the metatarsals, and then the toes are the phalanges. Going back up to the top, the bone in the middle here is the sternum, and we have the ribs, and the pelvis, which is actually made up of multiple bones fused together. Now, bones are used for locomotion and structural support for the body, locomotion being movement. And attached to those bones are going to be skeletal muscles. Those muscles are going to move the skeleton, and it works like levers and pulleys. If we look closer at the structure of bone, we're looking at the structure of a long bone here. We can see that the outer covering of the bone is the periosteum, and then inside the bone is along the long shaft of the bone is the compact bone. It's hard. If we look at the end of the bone, this is called spongy bone, and this is highlighted a little bit more for you. Spongy bone looks just like a sponge. It's holey, but it actually provides more elasticity where bones meet because they're under more compression where they meet at the joints, so the bone needs to be a little bit more elastic there. And within that spongy bone is the red bone marrow, where we're going to get the production of red blood cells. And then within the shaft of the compact bone here, we see the yellow marrow, and that's actually a site of fat storage. Through the bone, if we look even closer, all right, we look at the compact bone here. So this is a piece of the bone shaft. We see these haversian canals, and within those canals, we're going to find blood vessels. And remember, bone is a tissue, and if we look at the tissue closely under the microscope, this is what we're going to see. We're going to see these osteocytes, or bone cells, and that's what's making up this whole length of bone, and within that, they still need nutrients, and the blood vessels in those canals are going to carry the nutrients to the bone. I mentioned before, the joints where the bones meet, and there's multiple types of joints. The first one is a hinge joint, which is found at the elbow or the knee, and it's just like a hinge. If you move your elbow up and down, or your knee back and forth, that's a hinge joint. Not a lot of movement there. The next one is a pivot joint, and what happens here is there's going to be rotation of one bone around another. So if you turn your head around, that's actually working on a pivot joint. And the last one on this page is going to be a ball and socket joint, which is found in the shoulder or the hip. So take your arm and rotate it in a circle. That's that ball that's hooked into the socket, as you see this caricature here. That's what happens at your shoulder and hip area. There's a few other types also. We have what's called a saddle joint, and these are found in the fingers. Okay, it looks just like that. It's kind of overlapping. The condyloids are in the wrist, and gliding joints, which are in between the carpals in the hands. So those are actually gliding joints. They do just that. They glide back and forth. Now, if we go back to the structure of bone here, and I want you to remember the functions of the system. Okay, it's going to provide structure, movement, protection for the organs. It's going to make blood and help store minerals such as calcium. And to do that, it doesn't work alone. We have muscles that are going to be attached to the bones, and in order for those muscles to attach to the bones, there's going to be a connective tissue called a tendon. And the tendon is going to be, you're going to find a tendon anytime you see skeletal muscle attached to a bone. Now, those joints that we were talking about, they need to connect somehow. The bones aren't going to hold themselves there. So this tough connective tissue that's attaching bone to bone is going to be called a ligament. And in between these bones at the joints, we're going to find another tissue, and that's cartilage. And cartilage works like a shock absorber. And it's going to be found in between different bones, and it helps work as that cushion. So for impact, bones rubbing against each other, and so that's going to provide some protection between the bones. And remember also that as a baby, you actually have more bones than you do when you're an adult, because not all of the bones have ossified or fused. So there's many more bones, and the bones it appears softer. There's a lot more cartilage in a child. And as you get older, the process of ossification, okay, is the process of forming bone. It's actually the hardening of bone will take place, and it appears as if you have less bones than you did when you were born, but it's because those bones are now fused. The skull is a very good example of that, because there's multiple bones in the skull that are going to fuse together as you grow and become harder to protect the brain. But when you're a baby, you're still growing and developing, so they have to be able to grow with that.